You are with Cape Talk.
Views and news with Clarence Ford.
And it's Friday, That means we home a hound after 10 o'clock. And I'm looking forward to this one. And the other big appointment is, of course, the Naked Scientist joining us via Zoom from the UK. If you've got a question for him, keep it coming through via WhatsApp on 072 567 1567. You can also call us and you will jump the queue on 021 446 0567. Dr. Chris Smith is a consultant virologist at Addenbrooke's Hospital in Cambridge. A warm welcome, Chris. Great to have you back.
Good morning, Clarence. How are you?
I'm great. You're always commenting about my merchandise that I'm wearing. You're not going to say anything about my top
Actually, I can only see a headshot this time. You need to stand up a little tiny. Oh, I like it. Do you know? Yes, it says Dog Dad, and he's got a big paw print on the front. Looks good. I'm still waiting for my Cape Talk merch. It hasn't turned up. Must have been lost in the post or something.
No, Joe escalated that to management. Actually, Joe's pointing at Waleed. I think there's been a breakdown.
That sounds like a bit of buck passing going on here, doesn't it?
Well, there's a fight.
So did someone send you that in then? That looks good, that sweatshirt. Or did you not spot that on the rack and thought, I'll have that. That's one for me.
Yeah, my wife sorts out my wardrobe. So yeah, by and large.
Very good. Well, she's got good taste.
Yeah. But I like it, and I like it. I walk with it on the beach with my doggies. Dog Dad, I am indeed. There's been a lot happening in Cape Town. I think there's a couple of questions. Firstly, I spoke about recent disclosures by the U.S. government, and we're talking about UAPs, unexplained aerial phenomena. There's been a process of public disclosure. Videos, photos, and stories are there on www.war.gov.ufo or /UFO. They say that these particular videos, pictures, or stories are unresolved or beyond their scientific means of proof, whatever that means. But a lot of talk about interdimensional entities. And given, questions about M theory and string theory, we're just kind of wondering if things could be related. How does the math come into the equation?
It's interesting. I spoke to David Whitehouse, who is a former BBC Science journalist and also an author, and he's written a brilliant book called The Alien Perspective. And so we phoned him up earlier this week and said to him, what do you make of all these pictures that have emerged from the White House? And he was very dismissive, actually. I mean, this guy's an authority, so I trust his judgment. And he said he had a look at them and was extremely disappointed, not just in the quality of the images or anything, but he was disappointed in who had released them, because he said, look, these are bright people, ostensibly, from important US jurisdictions and entities who really, why they're putting out this sort of quality of material. He was quite dismissive. He was pointing to pictures that were blatantly balloons dangling in the ocean, to starburst pictures that you get as lens aberration from bright objects like flares released from a parachute, as he pointed out in one case. Other things where, Buzz Aldrin said, hey, I saw something weird on the moon, but in fact, on investigation, it was bits of rocket that they'd left behind whizzing past that were creating these strange effects. So most people who have looked at these images say there's nothing in here that floats their UFO boat. Really, there's nothing that really gets your juices flowing. And other people are pointing to the fact that there are other things happening in the world that perhaps it would be better if there was something juicy to get people talking about and filling column inches rather than other stories filling those column inches. And this might be a deflection tactic. I mean, it's just speculation. If you want to listen to the conversation with David Whitehouse, I'm actually going to publish it on the Naked Scientist website later today. So around about 6 o'clock UK time. So it's an hour ahead for you guys. But it'll come out this afternoon on the Naked Scientist, and you can hear what David, his much more thorough analysis than I can provide. And as I say, he and other commentators are saying, well, there's a huge and healthy conspiracy theory industry around this. People are making a fortune on the internet from the UFO field, because what they do is, even if you've got nothing to say, you make a video and put UFO on it and say, we're talking about UFOs this week. You'll get enormous numbers of people come and watch your video. They'll all watch the adverts because they're force-fed into you. The person who made the video doesn't have to believe a word they're saying, but they make a load of money. So you've got to be really careful, because this is a thriving industry.
Got you. Disclosure's a good thing because you can put it to bed one way or the other, though.
Well, that's the
Instead of
point that
keeping it
David makes
secret.
about conspiracy theories, because the problem is that people will then always go one step further and say, well, you would say that because you're part of the conspiracy.
Okay, well, fascinating. Janus is on the line. Janus, welcome. Go ahead for the Naked Scientist.
Thank you, Clarence and Mr. Smith. Thank you very much, Doctor. Listen, before the Industrial Revolution, there was no dirty air, the food wasn't poisoned, and people live about 30, 40 years of age, and they die, of course. And at the moment, we've got all this, these dirty things coming to our bodies. We've got CO2, the food is, chemicals there, and we live for 100 years old. So what's going on? How can we explain this phenomena? And also, for instance, is it possible that men can live the same age as women? Because at the moment, if a woman lives longer, what is stopping us to live? We are supposed to be stronger, isn't it? And then they live longer, and of course they retired earlier, at 60 like in our country, and they live up to 90 years old, and then we are leaving this world much faster, much quicker.
Hi, Janus. Well, first of all, let's think about this question you make about, or this point you make about the Industrial Revolution. We've actually got really good data on this because there are bureaucrats as far back as the Middle Ages, believe it or not. And so Britain being the nation of bureaucrats that we are, we have records to die for of all of this kind of stuff in painstaking detail. I have a friend who is a medieval economist. So in other words, he goes through all of these old records on parchment, many of them, detailing exactly who had what, where, who was working for whom, and how old they were when they died. And he's got records showing that, in fact, people did live well into old age, well into their 90s, in fact, in the 1500s. But the proportion of people who did that was much, much lower. So when we calculate life expectancy, what we're actually doing is saying, well, what's the average age at which a human being dies? Now, when you calculate an average, you basically add up everyone who you're considering, divide by the number of people you're considering, and that gives you an average. So if you've got a person dying aged 100 and a person dying aged 5, but then you've got 1 million people dying aged 5, it's going to shift the average down of life expectancy from 100 down towards 5. So people have always had the genetic potential and capacity to live a long time, but they haven't necessarily had the environment that enabled them to do it in the sorts of numbers that we on average have today. And the thing that's made the biggest difference to life expectancy, it isn't the thing that everyone points their finger at and says, look at the wonders of modern technology and medicine. Isn't medicine amazing? Look what medicine's done. We can show in population mortality and morbidity statistics that people were already living a hell of a lot longer and almost as long as they live today before antibiotics were even discovered. Before Alexander Fleming got his Petri dishes all messy with fungus and then discovered one of the most important drugs we've ever made, people were already living a lot longer. So what made a difference? It was living conditions. It was cleaning up water, giving people clean, fresh water to drink, taking sewage away more safely, sorting out housing so people weren't living in mass overcrowding, which leads to poor conditions, spread of disease, and generally damp, horrible environments. And they were also getting better food to eat. And that has made the biggest difference. And you're right to point the finger at other insults in the environment. We, on average, would be even healthier if we didn't have to contend with those. So we're probably actually at risk of damaging our health now in this era we're living in because we're actually polluting the world and breathing in pollution, and we're probably damaging our health, and we've peaked and we're coming down the other side at the moment. We need to clean up our act. On your point about men outliving women or women outliving men, at the moment, yes, on average, women do live longer than men. They live on average 5 to 10 years longer than men. There's a number of reasons for this. Women are relatively protected from some of the most common things that claim men's lives until the age of the menopause, because estrogen is protective against heart disease, which is one of the biggest killers in men. Also, socially, the generation of people that are in their old age and dying now were people who came from a generation where mostly men went to work and women often did more domestic things. That means that men were doing riskier things. They were down coal mines, they were on building sites, they were having accidents, and so the mortality rates for men were, and the accident rates, the injury rates were higher, and so that brought the averages down. We are seeing a narrowing of the gap in some places now because the way we're measuring these things and the sorts of jobs people are doing and so on is narrowing. So everyone across the world has seen their life expectancy increase, but you're right, there is still a disequilibrium, there is still a disparity between a man and a woman, and that appears to be also intrinsic to our sex, that men are destined to live a bit less long for various physiological reasons than women.
We've had a really big storm, and some people claiming a 150-year rainfall record in some areas. That makes it a very significant storm in the past week. Questions about that water running into the sea. Can you ask the doctor about the extra water running into the ocean? Does it impact the ocean system? Questions about there being a fixed amount of water in the world. Does an excess rainfall here impact another part of the globe disproportionately? Two other questions you may want to venture an answer on.
Well, first of all, the water running into the sea, well, excuse the pun, but that is a drop in the ocean. All that water came from the ocean in the first place because the sun shines on the sea and each square metre of ocean gets irradiated at the rate of about 1 kilowatt. So it's like you blowing a kilowatt hairdryer onto each square metre of ocean surface. That evaporates water. The water goes up into the air. It turns into clouds. Those clouds come over land. As they're forced to rise over the topography, they rain. The rain falls as water on the land and runs back to the sea as rivers. That's the water cycle. And unsurprisingly, if the water's come from the ocean and goes back to the ocean, there's no net change in sea level over time on average. It's not going to make a dramatic difference. Where it might make a difference is if you have gross flooding on land, which then washes lots of things into the sea that shouldn't be in the sea. And we're seeing big problems now where things like fertilizers and also animal waste and sewage and so on get washed into the sea because there are floods that overwhelm our ability to manage that water. This then fertilizes the ocean. And that fertilization of the ocean with things like phosphorus and other things that marine life absolutely flourish when they see it, in the same way as crops in a field flourish when they see these sources of nitrogen and phosphorus, you then get blooms in the ocean. So there can be sea consequences for flooding, but not because of water levels or anything like that. What was the other part of the question you wanted me to touch on?
The other part of the question related to excess rainfall here. Does it rob another part of the world of its rainfall?
Well, in some respects, the world is not a series of isolated geographies. What happens in one country is not happening in isolation. The weather is driven by the climate, and climate is sort of long-term patterns of weather, and that is driven by a whole load of physics, which is to do with how warm it is, where the energy is, how the water is moving around the earth, taking that energy with it. And so these things all follow patterns. And if you're seeing a lot of activity in one place, you're going to see corresponding changes in activity in another. If we take the El Nino phenomenon as an example, this is a pool of warm water that moves backwards and forwards across the Pacific Ocean. When you have a strong El Nino year, you drive a lot of rainfall over the Americas, for example, but that means that you're going to be depriving other places of that patch of warm water, so they're going to see a corresponding shift in their weather patterns elsewhere. You've got to think about the world as one big giant system, which is what climate scientists have been trying to do for a long time, to explain to people why climate change is an inevitability and why it matters.
Question in from Kevin. Good morning, Doctor. I listen to Cape Talk on the app on my cell phone. Whenever I put the microwave on, I lose signal. Why? And is this dangerous? Kevin in Claremont.
Hi, Kevin. The reason is that phone signals use microwaves. They actually transmit the data to and from the cell station tower in microwave format, about 2.5 gigahertz. I should say, if it's gigawatts, should be fried. That would be one powerful microwave. Yeah, about 2.45 gigahertz is the frequency, similar to Wi-Fi. And so when you turn your microwave oven on, it should be contained within the oven. But some devices do produce radio interference, and this can be very dirty. It cannot be discrete frequencies. And as a result of that, it can pollute the radio spectrum with random noise, which can sometimes be sufficient to drown out the signals that you do want to. In the same way that if I was listening to something on the television and then someone comes and puts a speaker in the room playing very loud random sounds, I wouldn't be able to hear what the television was saying. Your microwave might be producing radio interference, not just the microwaves used to cook the food, but there might be other components in there that are worn, bad connections can do it. They will produce radio noise, and that noise may be louder than the microwaves that your phone is hearing to download our program, and so you're temporarily divorced from the signal, so you can't pick it up.
And of course, the Naked Scientist, Dr. Chris Smith, our guest every Friday, just after 9:30. You're welcome to put that question that keeps you awake at night to him. Have it answered. Get decent sleep. And you can post it via WhatsApp 0725671567. You can call on 021-446-0567, and we'll prioritize your call. Keith says, Dr. Smith, can an ant accidentally enter a wrong ant hill, and the same with bees, into a beehive? And what's the consequences?
I have asked various entomologists, people who study these sorts of things, this, and they have said that actually ants recognize their own. When ants are interacting with each other, they're brushing antennae one to the other and onto the ant bodies, and ants produce these volatile compounds, these various things. They're ant BO, effectively, and bee BO. And the antennae are covered in receptors, effectively chemical sensors, that can detect this pattern of volatile compounds. And this is a unique fingerprint for each ant or ant colony. And so they can tell friend from foe. And this is how they'll tell, even though in the darkness underground they can't see, they can feel and tell whether an invader has turned up, because it doesn't smell right. So if a rival ant from another colony, not genetically related to that group of ants, comes along and just tries to wander into a random ant's nest, it will stand out by smell like a sore thumb. It will be attacked and it will be removed. I believe bees probably also know that it's not their nest and that they should steer clear. But if any bee experts know better, then do put me out of my misery. But I'm pretty sure the same is true for bees.
Okay, a question in about biology and our evolutionary angle. How would a higher dimensional organism even manifest in our limited 3D view? And that one from Anton.
I'm not sure we would be able to comprehend it, because if you think about, we've evolved to understand a number of dimensions. We understand what up and down is, left and right is. We understand time, and that's pretty much it. So if there was something outside of those dimensions that we can't appreciate, then we might be able to struggle to interact with them for a start, because if they were in a dimension that we're not operating in and sensitive to, we wouldn't even be able to see that they were there.
But we can perceive the first and the second dimension.
Yeah, so if they were existing in our space, then yes, we would be able to potentially interact with them. But if they're in some kind of dimension that's unknown to us and we do not know how to detect or interact with, they could be there alongside us and we wouldn't know. A way of thinking about other dimensions is, if you imagine a road. Now, one dimension would be a road going in one direction. Now imagine a crossroads. Now there is a road that's in one dimension, the original road, and a new road, which is the second dimension, the road crossing it. Now a car could be on one road in one dimension. Then we can have two cars on two roads, and actually they can have a crash where they interact in those two dimensions. But now let's add a third dimension. Let's add a flyover. So now we can have both our cars in the same original two-road dimension where they would have a crash at the crossroads, but we could put one car on the flyover, and the car underneath the flyover doesn't know the car is there above its head or in the underpass underneath it. They're both in the same X and Y dimension, but there's a third dimension up and down, and they don't know each other is there. So you couldn't see them, and therefore you would easily pass by and not know you've encountered them.
I'm not going to go to the fourth dimension, but let's go to Jonathan in Musenberg.
Well, that's easy, actually, Clarence. The fourth dimension is we have different cars arriving on those roads at different times, and therefore they don't know each other's been down that road. They both went down the same road, but they did it at different times. Therefore, they didn't see each other. That's an additional dimension. You can see how that's a simple, everyday analogy that enables you to appreciate what I'm trying to say.
Gotcha. Let's go to Jonathan. Jonathan, of course, I think, and this is in the wake of the storm as well. Jonathan, welcome.
Oh, hi, Dr. Chris. When wind blows, you get a decrease in pressure on the top of your roof. and that's what sucks the roof of the house. Now, if you open your windows, the pressure gets equalized a lot more quickly, and therefore your roof won't blow off. So isn't it a good idea to open your windows when there's a very strong wind blowing so that your pressure gets equalized so that your roof doesn't blow off?
Whoa, that sounds a bit daring to me. I think you'd have to be careful because if you open the window on the windward side of the building, the wind's going to blow straight into the house, and that will pressurise the house from the inside and be particularly disruptive, but it might blow the roof off upwards. If you open the windows on the downwind side, there is a partial vacuum, a pressure drop on the downwind, the lee side of your house. It's a bit like the car that goes down the road. The pressure behind the car is lower than the pressure in front of the car, and that's why all the dirt sticks up the back of your car and covers your number plate, because the low pressure draws all the muck into the vortex, low pressure behind your car. So if you were to open the windows behind your house, then I'm not sure that's really going to help because the pressure there is lower anyway. I think I'd probably just make sure I'd fix the roof in the first place.
Good advice. Is climate change causing more CO2 release from the sea now and in the future?
Potentially. Where am I going with that? Well, there's lots of CO2 sequestered on the sea floor in these entities called methane clathrates. Incredibly, when you have natural gas, which is methane, and there's enormous amounts of that under the surface of the earth because organic material has been buried, compressed, cooked up, and digested into methane, when this seeps out on the ocean floor, at the particular combination of low pressure at the bottom of the ocean and low temperature, the methane molecules stick together into these molecular cages, which are called methane clathrates. And occasionally fishermen bring them up, and they look like a giant ice cube. And they're weird because you can set fire to it and it will just burn like an ice cube, but a burning ice cube. And it is methane, which is slowly then, through the heat of the combustion, breaking apart and releasing more methane that then burns. So as ocean temperatures rise, more of that will decompose and come to the surface, and this will turn into CO2 ultimately, but is in itself a greenhouse gas. Also, you will elaborate a lot more CO2 from ground sources of carbon with rising temperatures because there's a lot of permafrost on Earth. This is land which is at the moment frozen because the temperature never gets above an appreciable amount because it's in cold parts of the earth, and there's a lot of carbon in the ground, and as soon as you raise the ground temperature and melt the permafrost, that carbon becomes accessible to microbial activity and digestion. Microbes start to break down those organic molecules, they release CO2, and they release it into the air, of course. And the sea can play a part of that because where the sea level is rising, the ocean is inundating land that's currently frozen, but the water isn't frozen, it's warmer. So the water warms the land, and the land then melts its permafrost and elaborates its carbon. So yes, you do get a risk of a positive feedback loop through rising ocean temperatures and rising sea levels, leading to an increase in rates of CO2 release into the atmosphere, which in turn compounds the problem.
We're going to have to wrap it there, but in appreciation again, the Naked Scientist, consultant virologist at Addenbrooke's Hospital in Cambridge, a feature every Friday at 9:30.